Hello students, today we will talk about relations and functions of 12th standard. To start with, we take functions. You have a little idea about functions from 11th standard. Today we go deep into it. Actually, function is a concept which is everywhere found in life. Even illiterates are using it without knowing that they are using it. For instance, any milkmaid in a village, she does not know how to count, but at the end of the month we get the counting by putting tally marks on the wall. Similarly, in olden days, umpires in cricket match, they used to use some stones to remember how many balls are bowled. So, function concept starts from matching. So, today we take up in detail. So, what is function? A function is a rule. We give a name to it, f x to y. Here x is a non-empty set, also y is a non-empty set. What does it do? Which links every element x of x to a unique element f x of y. It is a rule. It takes every element of the first set x, we call it domain, to a unique element f x of y, which we call codomain. Now, we have two remarks for it. Firstly, f x is called image of x and x is called, on the contrary, pre-image of f x. Thus, in a function we have two non-empty sets and every element of the first set, which we call domain, is linked to a unique element of the second set called codomain. So, wherever these conditions are met, such a linkage is called a function. Now, a function can also be represented in Venn diagrams. Usually, the left one is domain, the right one is codomain. If we link it like this, here the elements x 1, x 2, x 3 are linked to y 1, y 2 of the second set. Here y 1 is image of x 1, also image of x 2, y 2 is image of x 3 and y 3 is image of none. It is a function, but if you take the example this, this is not a function because x 3 has no image. We call it f x 3 has no image, or we can say f x 3 is not defined. Also we can say f x 3 does not exist. So, in a function every element must have image. Here x 3 has no image, so it is not a function, whereas this was a function. We take one more example. Once again, this is not example of function, because the element x 2 has two images, namely y 2 and y 3, whereas our requirement is every element should have a unique image. So, no element can have more than one image. It is again not a function. So, we had two examples of non functions, one in which some elements did not have image. Now, in this case every element has image, but some element has more than one image. So, uniqueness is defeated. Now, let us take some more types of examples. Is it a function? Yes, because every element has image and the image is unique. How about this? Is this a function? Let us check. First question, do every element have image? Yes, every element has image. Are the image unique? Yes, they are unique. So, it is also a function. Now, compare these two. Both are functions, but still we find some difference between these two, because here there is no free elements at all, whereas in this case there are some free elements. That is why this is called onto and this is called into. So, in an onto function there is no free element in the codomain. That means, every element in codomain has some pre-image, whereas into function there are elements which have no pre-image. Let us take one more example. In this case, is it a function? Yes, because every element has image and the images are unique, no problem. Next question is whether it is onto or into. Of course, it is onto because there are no free elements here. Okay. Compare these two, first and the third. Both functions are onto, okay, but still there is some difference between them. Can you guess? Well, in the first example there is no common image, whereas in the third example there are common images. So, even though both are functions, both are onto functions, still they are different in the sense, in the first case there is no common image, second case there are common images. So, this we call 1 function, whereas this is called many one. So, in this sense we can say we can classify functions into various types: onto, into, 1 and many one. So, our first example is an example of 1 onto function, whereas this is our 1 1 into function, and the third one is many one onto function. Naturally, in this block we expect a function which is many one as well as into. First we make it many one. But it is onto, now it is into. Thus, we classify functions in two ways. One is onto and into, other is 1 1 and many one. This was 1 1 and onto, this was 1 1 and into, this was many one and onto, and this was many one and into. Now, look, a function cannot be both onto and into at the same time. Similarly, a function cannot be 1 1 as well as many one at the same time. However, 1 1 can be both onto and into, many one can be both onto and into, onto can be both 1 1 and many one, again into can be both 1 1 and many one. It is not possible that always we have to take help of diagram to decide whether it is onto or into or 1 1 or many one. Sometimes the examples may not be given in the diagrammatic form. For instance, let us take the case f x is equal to x square. If I ask you what a function it is 1 1 or many one, into or onto, well, one cannot answer it at this moment, because we have no idea about what is domain and codomain. The nature of function depends on domain and codomain. At present, we only have a rule. So, unless we state domain and codomain, we can't answer it. Suppose the function is from x to y. Here again, we know the name of domain and codomain, namely as x and y, but still we do not know what is x and what is y. So, we have defined first x. Suppose your x is 1, 2, 3 and y is 1, 4 and 9. Now, my question is whether it is a function in the first case where x is 1, 2, 3, y is 1, 4, 9. Yes, it is a function, because every element has image. For instance, 1 has image 1, 2 has image 4, 3 has image 9, and no element has more than one image. So, it is a function. The next question is, it is 1 1 or into. Look at the codomain. 1 has pre-image 1, 4 has pre-image 2, 9 has pre-image 3. So, it is onto function. Next question, it is 1 1 or many one. Yes, the image of 1 is 1, image of 2 is 4, image of 3 is 9. So, there is no common image. So, it is 1 1 function. So, eventually this function is 1 1 and onto. That is not all. Suppose x is changed a bit. Y remains the same. Is it a function? Yes, because every element has image and no element has more than one image. Is it onto or into? Well, 1 has pre-image 1 and minus 1, 4 has pre-image just 2, 9 has pre-image 3. So, it is onto function, because there is no free element left in codomain. How about 1 1 and many one? 1 has image 1, also minus 1 has image 1. It means two different elements have same image, that is, it is a case of common image. So, this is many one and also onto. So, look at the case. Merely f x is x square cannot decide the nature of function unless we know the domain and codomain. Take third case. X is 1, 2, 3, 4, y is 1, 4, 9, 16, 25. First question, is it a function? Yes, because every element has image and no element has more than one image. So, it is certainly a function. Next question, it is 1 1 or many one. Here image of 1 is 1, image of 2 is 4, image of 3 is 9, image of 4 is 16. There is no common image, so it is a case of 1 1 function. Next question is, it is onto or into. Here coming to the codomain, pre-image of 1 is 1, pre-image of 4 is 2, pre-image of 9 is 3, pre-image of 16 is 4. How about pre-image of 25? Well, there is no pre-image of 25, hence it is a case of into function. Let us take fourth case. We have x is 1, 2, 3, 4 and minus 2, y is 1, minus 1, 2, 3, 4, 9, 16. Now, the first question is it a function? Yes, of course, it is a function because every element has image. Next question, it is onto or into. Well, look at the domain and codomain. In the codomain, number 3 has no pre-image in the domain. So, it is case of into function. Next question is whether it is many one or 1 1. Look, here 1 has image 1, 2 has image 4, 3 has image 9, 4 has image 16, but again minus 2 has image 4. So, 2 and minus 2 both have common image. So, it is a case of many one and on into. Thus, we see that the same rule can be of different nature if the domain is slightly changed or codomain is slightly changed. Today, we discuss the concept of function, its types. We classified function in two ways, one as 1 1 and many one, and other way is onto and into. These qualifications are very important in dealing with functions in detail later on. The next episode we will take further more examples of the types of functions. Thank you.